video we are going to see the solutions. Okay, now for this problem, the one that we saw in the previous video, we have the matrix equation like this. Derivative of x vector equal to a matrix, or in this case the matrix A happens to be 1, 3, 5, and 3. X vector. Now, the problem tells that this is the first solution and this is the second solution. How are we going to get that solution? Well, that's on the next video. But for the moment, let's prove that they are or not solutions. Okay, so for the first one, let's try this one here. Okay, so x1 vector is equal to 1 and minus 1 and the exponential minus 2t. Okay, let's see if that happens to be a solution. So on the left, here on the left, what we have to find is the derivative of x1 vector respect to the time. Okay, so what is the derivative of this? Derivative of the exponential. So these two numbers are the same, 1 and minus 1, but here the exponential happens to be derivative of this minus 2 exponential minus 2t. Okay, if we introduce the numbers, here is going to be minus 2 exponential minus 2t, and then minus and minus 2 exponential minus 2t inside of the vector. Now this is on the left. Now let's do the right operation. On the right operation, what we have is 1, 3, 5, and 3, and then x vector, the A matrix times the x vector, and the x vector, this is the solution, this is the proposed solution. Okay, so it's going to be exponential minus 2t. If we introduce the exponential inside the vector, minus exponential minus 2t. Let's do the operations. Okay, so this row times this column is going to be exponential minus 2t minus 3 exponential minus 2t. Okay, and then this row times this column, 5 exponential minus 2t, and then minus 3 exponential minus 2t. So what is the result of this? Now, 1 minus 3 minus 2 exponential minus 2t, and then 5 minus 3, 2 positive, 2 exponential minus 2t. As you can see, this number and this number, they are the same, which means that the derivative of x1 vector respect to the time is equal to the A matrix x1 vector, and this is true. So it is solution, because this is equal to this, then it is solution. Okay, now that was for the blue one. What about the other solution? Okay, same procedure to check if it is solution. So we have to calculate the derivative. We have, sorry, here I missed the derivative respect to the time. So what we have to do is take the derivative of x2 vector, the solution here, respect to the time. Okay, so 3 and 5, I don't change those values because I'm taking the derivative of the exponential, so it's going to be 6 exponential of 60. If we introduce the numbers inside, it's going to be 6 times 3, 18 exponential of 60, and 6 times 5, 30 exponential of 16. Okay, that was the left side. Now, on the right side is A matrix times my x2 vector. Okay, let's see if what happens. So what you have is 1, 3, 5, 3, and then the solution. This is the solution. I'm going to use the numbers inside of the vector. 3 exponential of 16, and then 5 exponential of 16. So the multiplication is going to be this row times this column. 1 times 3 is 3, and 3 times 5, 15. 3 exponential of 16 plus 15 exponential of 16. And then this 5 times 3 is going to be 15 exponential of 16, and 3 times 5 is going to be plus 15 exponential of 16. So what is the result of this? It's going to be 18 exponential of 16, and then 30 exponential of 16. Now this happens to be the same as this one. They are equal, alright? Now this is the derivative. So what we have proved is that the derivative of the second solution with respect to the time is equal to the A matrix times my second solution. So it is also a solution. Because we have proved that both are solutions, then what we usually do to write the result, the final result, is just the general solution. The general solution is going to be C1, my first solution, and my first solution is 1 minus 1 exponential minus 2t, and then C2, my second solution, is going to be, the second solution is 3, 5 exponential of 16. It's just the linear combination of the solution C1 x1 vector plus C2 x2 vector. So this is the final solution, and that's what we are going to try to find, engineers. In the next video we are going to see how to find x1 vector and x2 vector. What I can tell you from now is that the solutions, the proposed solutions, are like these, engineers. We propose the solutions to be a vector times an exponential. So in the end, the proposed solution is going to be x vector equal to some vector that we don't know what is the values, k vector. What we need to find is what is this vector, and we also need to find what is the exponential. So what we have to find is this vector and this number, and this vector and this number, because they have the same shape. The difference is the vector and the values. How to find the values of x vector and lambda. Okay, so you have already seen that before in linear algebra. K happens to be the eigenvector, and lambda happens to be the eigenvalue. But we will see that on the next video.